Okay, so we're going to look at two quick theorems from the geometry course. So this is the triangle midsegment theorem, and so it's really nice, really quite simple too. So if we have a midsegment, and a midsegment is nothing more than a line connecting two midpoints. So here we can see that R and Q are both midpoints of their respective sides because R is halfway between the endpoints, as is Q. So this line connecting these two midpoints is what we call the midsegment. When you have a midsegment of a triangle, that means that this midsegment is half of the distance of the third side. So that means this distance RQ is going to be half of this whole distance. So if we want to solve for x here, we have two options. We can either say, all right, well, 1/2 of x minus 2 is equal, we can either say that 1/2 of the larger side, x plus 3, is equal to x minus 2, or we could say that 2 times x minus 2, so double the shorter side, equals that larger side. Now both equations will give you the same answer, but I know for some of us we see this fraction and we panic. So if you want to avoid the fraction altogether, you can solve like this, and what we get is 2x minus 4 is equal to x plus 3. Now, if you do use the fraction, you can actually avoid by taking the entire equation and multiplying by the common denominator. Common denominator is just this 2. So we multiply everything by 2, and we get x plus 3 is equal to, oh, look at that, 2x minus 4. So we end up with the same equation. So whether you set it up that RQ is half of SU or SU is 2 times RQ, you still get the same equation. And we can solve by subtracting x from both sides and adding 4 to both sides, so we get that x is equal to 7. And if we want to find the distance RQ, that's going to be 7 minus 2, so RQ is equal to 5. That's the triangle midsegment theorem. Real quick, real simple, real nice. Now there's also the converse of the triangle proportionality theorem. So if we want to solve for x here, and we have this, we can see that if this whole side is 28, this side is 8, this must be 20. This is not a midpoint, so this is not a midsegment, so we can't just set it up evenly. If we want it to, because these are going to be similar triangles, you can see this triangle here and that triangle there, they overlap each other. You could break it apart as two different triangles, but that's a lot of work and it's a lot of extra steps. Instead, this theorem says, well, we can set up these proportional sides. So we can say this short side to the long side equals this short segment to the long segment. So we can set up 8 to 20 staying on the same side equals 10 to 3x minus 5. And there we can see a nice proportion. So again, segment to segment equals segment to segment. We can reduce this fraction to make multiplying easier. 4 is a common factor. So I get 2 to 5 is equal to 10 to 3x minus 5. Cross multiply, so I get 6x minus 10 is equal to 50. Add 10 to both sides, so I get 6x is equal to 60, or x is equal to 10. Again, really nice and simple, so just make sure you get enough practice in so you're familiar with this. With similar triangles, we go corresponding parts, so it's a common mistake to say 8 to 10 equals 20 to 3x minus 5. You have to be very careful with that because this theorem says it's just segment to segment. So watch out, know the theorem, and get some practice. One quick note, sometimes you may have a triangle like this. And so this whole large side, that's the unknown x. So we have to figure out what we're going to set up. Well, this segment here is 9 because the whole side is 24. This segment is 15, so 24 minus 15 is 9. So we can say 15 to 9 equals 25 to this distance here. Well, what is that distance? It's not x, because x is the whole side. Well, if this whole side were 30, this would be 5, because 30 minus 25 is 5. But I don't know what this large side is. So instead of it being 30 minus 25, I'll just say that it's x minus 25. And now I have this beautiful proportion I set up, and I can cross multiply to get my answer. So 15 times 25 is 375, so we get 15x minus that 375 is going to be equal to 25 times 9, which is 225. Oops. So we get some big numbers here, but that's okay, because actually when we add 375 to both sides, 75 and 25 is 100, so we're going to get a nice even 600, and then we divide both sides by 15 to get x is equal to 40. So nice 3 simple theorems that really just have complex algebraic maneuvers about them. But again, get some practice. We've gone over plenty of problems in class, and let me know if you have any questions.